Awesome. We are live. Hey everyone. Welcome to another Kubesimplify webinar. Pretty excited for this one. And my name is Kunal. I am working as a dev rel at Kubesimplify, trying to grow and grow the community along with Sayam Patak. And pretty excited for this one because we have Anthony with us joining from Portainer. And today we are going to discuss about a pretty interesting tool which was surprisingly released earlier this year only in, I believe, in July 2023. And it's called as K2D. It's Kubernetes to Docker Translator. Now, for those who are joining in the chat, if you are already familiar with other Kubernetes distributions, you might imagine that, oh man, another Kubernetes distribution being added to the list. But that's actually not the case, and and the use case is pretty unique when it comes to running Kubernetes on edge and on the IoT devices. So that is what we are going to discuss today. And Anthony, welcome to this particular stream. Would like to tell everyone a little bit more about yourself and what you do?
Definitely. Thanks, Kunal, for the introduction. I'm Anthony Lapena. I am the co-founder of Portainer. For those who don't know or never heard about Portainer, Portainer is a container management platform allowing you to manage your application, your containerized application over different container platform and orchestrator, from Docker to Swarm to Kubernetes. Original goal with Portainer has always been the same since its inception, which was to make the container technology available to everyone. Nowadays,
Awesome. Yeah.
we're gonna talk a bit about something a bit different, but yeah, definitely.
Definitely, yeah, pretty excited. And as I mentioned, K2D has a pretty unique use case. I was introduced to this tool very recently before this particular stream, and I explored it, and I actually was really intrigued by what the tool is capable of in the Kubernetes distribution sector. But yeah, pretty interesting to learn more. And Anthony, if you're ready, you can share your screen and we can take it away.
Definitely. Let's have a look. Let's have a look at K2D. All right, so
Awesome. And I already see folks joining from the chat. By the way, if you have any questions that you want to ask, just drop them in the chat and we'll take them after Anthony has done presenting. And yeah, let's do it.
okay, great. So let's have a look around K2D today, and especially how can we use Kubernetes at the edge in specific industrial IoT context, which is basically the use case behind K2D, but we'll dig a bit more into that during that presentation. So I've already talked a bit about me, but I guess we're just gonna go again through that slide. This is me, software engineer, co-founder of Portainer. The most important part here is that I've been working with Go, Docker, and Kubernetes for the past 5 or 6 years. Been building a lot of experience around it, and yeah, again, my aim is to make the container technology accessible for everyone. So that's just a bit about me. Here we're going to just set a bit of background for this presentation, right? So I'm not going to actually dig deep down into why you should use Kubernetes at the edge, or use containerization at the edge. But there are definitely benefits of using containers at the edge. Some of the main benefits are the resource efficiency, because the containers are lightweight, they're portable, but that's just amongst other advantages that containers have. That's just for containerization in general. Now, why would you use Kubernetes? Well, like it or not, Kubernetes really won the container management tooling war, the container orchestration war as well. So nowadays, when you're looking at a solution or documentation or anything that is related to deploying a container somewhere, it is very likely that you'll find these instructions in the Kubernetes language. Very likely. So this is mostly why you'll see Kubernetes making its way into that edge space, purely because of the fact that it is now everywhere. It is now the de facto way of deploying containers. However, let's dig a bit into the challenges now of running Kubernetes at the edge, right? And for that context, for the context of this demonstration, this presentation, and for the context of K2D as well, we try to experiment with different kinds of Kubernetes distribution that are available out there that are supposed to run at the edge as well, or tailored to run at the edge. And in our example, we went with a very resource-constrained device, something very small, 1 gig of RAM, 1 CPU, on the disk actually stored on the SD card. And then we tried to play with different distributions, such as K3s, K0s, and micro K8s. Turns out that we didn't found any that has a out-of-the-box, that is actually out-of-the-box suitable to run on these kind of devices. We faced two major problems when we started playing with these. The first one was the high memory usage of Kubernetes just while idling on the device, taking as much as half or more than the memory available, leaving us with a very, very short amount of memory to run our applications. And the other issue that we found is that Kubernetes itself, just to maintain its quorum, just to actually, again, just idle, is causing an excessive amount of I/O, which can lead to your SD card wearing out very quickly. These are some of the challenges that we found, which led us to, right, how can we actually solve these problems? We still want to help people go and deploy their Kubernetes manifest, which are the de facto way of deploying it on their edge devices, even though we're facing this problem. So this is why we introduced K2D, why we built K2D, which is a Kubernetes to Docker translator. And its entire goal is to bridge the power of Kubernetes and that orchestration and management power with the resource efficiency of Docker. Right, Docker is lightweight. It can run on this kind of device without taking too much RAM and producing too much I/O. With that in mind, this is a bit of the background around K2D, but we also focused, when we designed it, on very, very specific use cases. And we're going to talk a bit about the use cases afterwards. But we focused on specific use cases, and we tried to keep the resource-constrained devices in mind. With these two, this is basically the foundation of K2D for the design of K2D. And yeah, it's just a single container. You only need Docker or Podman on your device, and then you just have to run the K2D container, and you'll be ready to use Kubernetes on this device. So I was talking about very specific use cases, and we're gonna explore that a bit more here. This is exactly the kind of use cases that we had in mind when we designed K2D. And the first one is actually the most important one for us. This is where we're gonna talk about industrial edge computing. Here we're going to talk about managing the applications that are running on a plant floor machine, or definitely on the plant floor. And there you'll find plenty of different kind of devices that are interfacing with the machinery running on the plant floor. And we're going to talk about the kind of devices such as edge controllers, edge devices, industrial PCs, these kind of things. These kind of devices are supposed to run the Industry 4 software stacks nowadays. That are going to take care of connecting, with the machine, doing protocol translation. There's also a lot of MQTT brokers running again that stack to actually transfer the information and data. So this is the very specific use case that we originally had in mind. And most of these devices that I'm going to talk about here are very, very small, very lightweight, and don't have a lot of resources available. Other use cases, though, that were into our mind when we designed K2D were potentially retail and distribute. Other example is distributed camera system, which is a smart city example, for example. But for the retail part of it, you could picture the management of a point of sale at scale across an entire country, for example, which might be running a complex application stack. But the entire point here is to maximize the available compute on each device for the application execution. And it's pretty similar for the distributed camera systems. Again, inside potentially a smart city project or something a bit different. But the idea here is to manage at scale a lot of devices without the overhead of Kubernetes running on these devices. So with this is what you have to keep in mind when you're saying, should I be using K2D, or why K2D was created? And overall, these three use cases are going to come back to the same really problematic here, which is resource optimization. K2D was designed for devices with limited resources in mind, and we're talking about very specific CPUs and very low amount of RAM. Here I'm talking about 2 gig of RAM in this presentation, but even 2 gig of RAM is quite huge for this kind of device. So the real point is to preserve as much memory as we can, so as much resources we can for our applications rather than the orchestrator tool that is running on it to make sure containers are running. So the next step here, we're gonna do a quick comparison of what's possible with K2D, what's possible with the other distributions. The entire point of this here is to be able to see that, yes, there's benefits. Where are the benefits of K2D? But K2D also has limitations, and I want to talk a bit about the limitations afterwards. So that's why I'm trying to introduce this table here to discuss a bit about it. So we've compared, as I was discussing earlier, micro KS, K3S, K0s, and then we've got K2D in the end. We have made sure that we have full client support, full Kubernetes client support, as all the other distributions have. And here I'm talking about connecting to K2D using kubectl, using Lens, using Argo CD, using K9S, you name it. There's a lot of Kubernetes clients out there, even just sending HTTP requests directly to K2D using the Kubernetes API. So we made sure that we can cover the same toolkits when it comes to client communications. Regarding platform supports, most of these distributions are supposed to cover the most common platforms that you will see at the edge, which are mostly going to be ARM for sure and ARM64. In the industrial space, even more ARM32 actually, outside of MicroKS, which does not support this platform. And the interesting part here, the interesting distinction between these other Kubernetes distribution and K2D is the resource usage. And here I'm just showcasing memory when actually idling. As we can see, we try to do a bit of a difference between having your Kubernetes distribution running and your OS versus how much that actual distribution takes out of the OS. So in most of the cases, it's going to be around half of a 1 gig of RAM device. So the memory is going to be half of the memory is going to be used for running the entire distribution. Bear in mind that in order to strip down MicroKS to that level, we had to remove some components like high availability and these kind of things to make it just a bit smaller on the resource footprint. And when it comes to the comparison with K2D, on our side, we're just running DOS and Docker and K2D, and all that amounts for around 220 meg of RAM. K2D in itself is a single container, very, very lightweight. It's just 10 megabytes of RAM usage when idling, right? So that's what I was talking about earlier when we kept these resource constrained device in mind. This is why this thing is very lightweight. It comes with this trade-off, though, being super lightweight and also focusing on our use cases, as I was talking about earlier. We decided to either implement some things that are available in Kubernetes or not. So, for example, role-based access control, which is a feature of Kubernetes, is actually not implemented in K2D. Now, there's a question where does that make sense for us to have to support role-based access control when you want to run your application in these kind of devices on single devices that is running on the factory floor? I don't think so, but these are the discussions that we can create and potentially look forward in the future. Clustering, though, is not implemented, but might be useful in the future. But this is not available right now. And finally, potentially the most important one here is that K2D do not support all the Kubernetes resources available at the moment. We have aimed to select a very specific set of resources that we think are the one that we wanted to support, and I'm going to talk a bit more about that right after that. But the point is, yeah, we're not supporting everything that Kubernetes has to offer. And that's why we're also that lightweight, right? There's not going to be CRD support, there's not going to be role binding support, and these kind of things. So if we look at what K2D actually support at the moment, when again we're talking about translating, right? Translating these kind of resources into Docker equivalent to a degree. This is all the resources that are currently supported by K2D. So we have cluster resources such as the ability to create namespaces, to list a node, as well as your persistent volumes that are available in this specific node. Regarding workload, we decided to go just pod and deployment support. Then again, we thought that it was just enough to actually deploy our workloads or kind of industry 4 application stacks on this type of device. No need for the stateful set management, no need for the daemon sets. But potentially we'll see whether we need actually that in the future. One important part was storage regarding container configuration. So country map and secrets are supported. We have also support for persistent volume clades, and we have basically implemented a default storage class in here. Finally, you also need to be able to expose your application, so we have added server support inside K2D as well. So as you can see, this is a pretty limited resource set that we support at the moment, but this might evolve in the future, and then again, this might be just enough to run the application you need at the edge in the industrial space. I just emphasize on that bit. So yeah, with all that in mind, the comparison, the supported features, supported resources, when should you technically use K2D, right? Well, if you are able to run Kubernetes, vanilla Kubernetes distribution on your device, and you think that it is actually okay for you to let Kubernetes eat as much memory as it is on your device, and you have just enough to potentially run your application, then just run this kind of distribution. If you're in the situation where you really don't want to compromise on the available resources on your device, and you know that all the Kubernetes resources that are part of your manifest or your application definitions are supported by K2D, then you should definitely give it a go, and it's potentially going to help you exploit as much as you can, exploit the resources available on your devices as much as you can. Okay, let's have a look at a bit of a high-level architecture diagram here and how it works before we dig into a demonstration. So as I was telling you earlier, K2D is basically running as a single container on your device, your host. So you just need to have Docker or Podman installed, and we'll see how the deployment instructions are in a bit, but you just need to make sure that your K2D container can talk to the Docker daemon and to the file system as well. But basically, there's three main components inside K2D, which are the API server, the controller, and the adapter. The API server is responsible from mimicking and handling all the Kubernetes API requests that are coming in, right? So as you can see on the left side of this diagram, we've got different kind of clients that are going to talk Kubernetes to K2D. It's all authenticated through a specific kube config, as you would do with a native Kubernetes or a vanilla Kubernetes distribution. And every request is going to be handled by that API component. The next thing that API component is going to do is that it's going to actually redirect the request based on the kind of request that is. So for any kind of resource creation, of Kubernetes resource creation, I'm talking about creating a namespace, creating a pod, creating a persistent volume claim, these kind of things. Everything is going to be redirected to the controller, which is going to take care of processing these asynchronously, as how Kubernetes is doing things. But you're also going to make sure that it assigns different level of priorities to each resource. Because, for example, when I'm deploying an application that could be a Node-RED or something similar, as we can see, we're going to see next in the demo. But when I'm deploying a container and I need a config map, so there's going to be my pod, my deployment, it's going to be a config map, it's going to be a namespace. I need to make sure that there's some order here that's going to be respected, right? So we need to make sure that namespace is created first. We need to make sure that the config map is going to be available next, and then we can create our container to leverage all these dependencies. So that's the role of the controller here. It's going to make sure that everything is actually tagged with specific priorities, and then everything will go through the adapter. The adapter responsibility is to basically leverage a converter and the store subcomponents to translate requests from Kubernetes to Docker. So that's the role of the converter. And then we have some kind of store layer that allows us to store secrets and config maps as file directly on the file system so that they can be bi-mounted into our containers next. Yeah, so that's just a pretty high-level presentation of K2D. Next, I think it's time to dig a bit into a demonstration. So I'm going to switch to another screen here. All right. Let's have a look here. So yeah, you should see my terminal right here. Here I have a small virtual machine, which just as we can see here, look at the resources available on that device.
Anthony, sorry to cut you there. Can you please increase the font size a bit of the terminal?
Oh, yeah, awesome. Yeah, always.
Yeah, I think that's perfect.
Here, but is that better?
I think that's perfect.
Yeah.
Thanks.
That's a small Linux Ubuntu server machine. I think it's got a total of 512 megabits of RAM available. Total RAM on the device, on the machine. And as we can see here, we have Docker installed. We still have a bit around half of it available to run our system. So the next thing we're gonna do is that we're gonna go and install K2D. So I'm just gonna go on our documentation website here, which is docs.k2d.io. And I'm just gonna grab the deployment instructions, so you can just go into the installation section, and this is how you need to run K2D. There are a few specific options that you need to pass. The most important one, though, are the advertising address and the secrets that you want to pass to K2D. So the advertising address is going to be basically the IP address of the host where K2D is running. And finally, the K2D secret is the secret that you're going to use to retrieve your kubeconfig file to be able to interact with K2D later. So we're going to use that command. Grab this here. All right. This is the command I'm going to paste on this specific device. So I've got the address. I have put my strong secret as my own secret. If you don't put the secret when you deploy K2D, it is fine as well. K2D will generate one for you and will output the command that you need to paste in the logs or to use to retrieve your own kubeconfig file. So let's have a go. As I said, very lightweight container, very easy. It's going to be downloaded very fast. And if we have a look at our Docker container, we can see that this is actually running. Perfect. So our next step is going to be to retrieve our kubeconfig file from here. So let's go into the usage section of the documentation. And it's basically telling us to send a curl command to the K2D API to retrieve our kubeconfig. And this is where we have to specify our own secret. So, right, Kubernetes is exposing, K2D is exposing its API, but you cannot access it if you don't own the secret. So this is your security layer in front of it. I'm going to grab my command as well here. I'm going to execute it on the device. We can see that this returns, this returns a kubeconfig configuration that we can use. So what we're going to do with that is that we're going to store it into a .cube folder inside the config file. And now we should be able to use look at this now. We're talking Kubernetes, right? We're going to use Kubernetes. We're actually using kubectl to retrieve information, but behind the scene, this is Docker running. So we can see that we have a few namespaces running. If I look at all the pods available, I can see that I have a K2D pod that is running in the K2D namespace. So this is all looking good. I can interact. I can start playing with Kubernetes clients and manifest. So that could be, Lens, that could be Portainer itself. It could be Helm, these kind of things. For the sake of a demonstration here, what we're going to do is that we're going to deploy let's say, IoT manifest directly on that machine. So if we go on the website, on the documentation website, we're going to deploy a Node-RED application on that device. So I'm just going to copy and paste that command, which is just a kubectl apply of this manifest here. And I've got access to Kubernetes as kubectl. All right, and we can see that it created the namespace, created the deployment, a persistent volume claim, and the service. Yeah, this is basically, if we want to have a look at the manifest here, we're going to say the same. This is what we just deployed, right? So we got our namespace definition, we got a deployment definition using specific image, using specific security context, and these kind of things, or persistent volume claim, and or service to actually expose our application over the network. So let's have a look. Did it actually work? We can do a get namespaces. You can see that there's a Node-RED namespace. Let's have a look at all the pods available into that namespace. You can see our Node-RED container is running. That's nice. And we get the logs out of it. can actually also see the logs, directly of our Node-RED container here. And finally, the most interesting part for us is going to be to see whether we can access that application. So let's have a look at our services. We can see that we have created automatically a load balancer type service. This has an external IP that is mapped to the host IP, and I can use that to connect. So I can use that 170.64 to access my Node-RED application. So I should have that URL already pasted in here. Let's have a look, and we can see that we can access that application, right? So we've been able to deploy our Node-RED application directly from a Kubernetes manifest with Docker running on that device. And if I just come back to that machine and have a look at my resources available here, I can see that I still have 180 megs of RAM available just to run other kind of applications here. So this gives me most freedom when it comes to running more applications on small devices. So yeah, that's one of the way that's the main way of actually using K2D and Kubernetes with the Docker powered in the background, Docker powering your device in the background. One of the interesting thing that happens as well on this is that K2D also allows for bidirectional management. So that means that, for example, we've seen that we could use kubectl, any form of Kubernetes client to see the resources that are available on your machine. That also means that if I actually start to have a look with Docker, I can also start looking at the resources available on my machine here. So I can see that I have containers running. I can see that I have some volumes that have been created here. So I can also see that different networks have been created as well. So how does that kind of works from a bidirectional management thing is that we are mapping specific Kubernetes resources to specific Docker resources. A namespace, for example, is basically a Docker network where all the containers are going to be running in and going to be able to talk to each other through that namespace, through that Docker network. Deployment is going to obviously be transformed as a container, and things like persistent volume claim, counting maps, secrets are either going to be transformed as file directly on the file system, where K2D will be able to do the bind mounts for you on the container. And for persistent volume claims, we're just translating them as Docker volumes. So yeah, definitely you can use that as a bidirectional. You can make use of that bidirectional management. For example, if I want to deploy a simple Mosquito container on that machine, and I'm just going to use Docker here because maybe some of the people in my company are more familiar with Docker. So they just wanted to experiment and they just were playing with Dockers. And on the other side of things, I have another team that is more fluent with Kubernetes. If I look at all the pods available after running that container, I can see that my Mosquito container, which I should probably have named, has been created and added to the default namespace. And, even though I've created the container as a Docker command, again, I can still manage it through Kubernetes lingo, right? So I could technically get the logs as well from that Mosquito server, etc., etc. So this is one of the things that we also try to keep that bidirectional management from K2D. Now, this is basically what K2D is about at the moment. I just want to showcase one last piece, one last example for my demo, which is going to be the Portainer integration that we've built as well within K2D. So if we look at the advanced configuration part of our documentation, we'll give you some information about how you can automatically connect that device to a Portainer server running wherever you have in your infrastructure when you deploy K2D. So basically, when you deploy K2D, you're going to use the same command as we used before to deploy the K2D container on your device, but you're going to pass some extra parameters. And you're probably the only two extra parameters that you need to pass actually are an edge identifier and an edge key. The identifier is the unique identifier of that device inside Portainer when it's going to report into your server. And the edge key is basically the token that's going to be used by K2D to find where is the Portainer instance running. So here in my use case, I've got a simple Portainer instance that is deployed here. And we're going to retrieve that token by going into environments. We're going to use the auto onboarding feature of Portainer here and grab the token from the Edge Agent Async tab here. So we just want to grab that specific piece, that specific token. And And I'm gonna use that command. I put it aside here, deploy it on a specific device. So I'm just gonna grab another device that I had here, which is the same thing, another small device. It has Docker running, and yeah, I want to deploy that specific container here. As we can see in the command, very similar to the other one, except this time we're passing a edge ID, which is using here our hostname. So when this device reports back to Portainer for management, we should see K2D Demo 11/2023 device 2. And we have the edge key of the Portainer server available here, which should help connecting our device to that Portainer instance. So what's going to happen here is basically the bootstrap or the startup process of K2D is going to be very similar to the other one, except that it's going to start the Portainer agent automatically as part of its deployment. So if we wait for a bit here, we should be able to see a Portainer agent running at some point. The Portainer agent is pretty lightweight, so you should see it popping in. So as we can see here, our Portainer agent has been deployed and it's right available over there. So let's have a look at our Portainer server then. Back to the Portainer server. I'm just gonna hit the waiting room, and ultimately my agent is going to report back in here. So it's gonna take a bit, or it should take around a minute to automatically be added to the waiting room. Just gonna have a look at logs of my Portainer agent just to make sure there's no communication issue and that the communications are actually going through. Seems to be looking good. Now we just need to wait for a bit. The entire point is ultimately it's going to take a minute or so to actually report back in. We'll have automatically deployed K2D or agent, and now we can use Portainer to centrally manage that device. So this can be applied to multiple devices if you want to put that into a golden image and just spread that out to all the devices that you have available on a on factory floor, for example. And the entire point is that once your device is actually onboarded inside Portainer for management, then you can use all the application management capabilities of Portainer. This is where you'll be able to deploy at scale and troubleshoot your application deployments, etc., through the use of edge features, edge groups, edge stacks, etc., etc. So that's what we're going to use to manage our devices. Yeah. So I think it should be coming in, and here we go. We have the device coming into the waiting room of Portainer. From here, we can basically select it and associate the device with that Portainer instance. Now, if I go back to my home view here, I can see that the K2D demo device has been onboarded. The RBit is currently red, but it should shift to a valid RBit in a moment, and now I can manage that device. All right, then that's going to be all for the demo. Let's go back to the presentation. Yeah, pretty much. This is pretty much where K2D is at the moment. So as Kunal was saying, the alpha version of it was out around July this year. And we did go through an alpha and beta testing program. And the first release of K2D, which is the release 1.0, was released this week. So we're now looking for feedback, which is available for you to go test the software and give us some feedback as well if you want over the K2D repository under github.com/Portainer/K2D. We'd be very, very happy to hear what you think about it after you've played with it. Another thing that I wanted to add into this presentation is a side effect, or not really an intended use case, but we had some users playing with the alpha and the beta version of K2D, and we found that use case very interesting, which was basically someone tried to use K2D in their CI pipeline. So their entire point was to actually build and test that their application are running inside Kubernetes. And as part of that, they were actually, spinning up K3D environments to actually deploy the application and do some tests. And they thought about actually replacing that specific component, the specific K3D component, with K2D, which is very lightweight, as I was telling you earlier. and that accelerated their entire CI pipeline execution, which was very nice. Again, this is not really our intended use case, but it is nice to see this kind of other use case put in. Let's talk a bit more about the licensing part of K2D. As you can see, it's available on GitHub. It is licensed under BSL license, so that's going to be free to use for non-production usage. But if you want to use K2D in production environment, you will require a Portainer node license for that specific node where K2D is running. So you can refer to our website for more information about that, but it starts from $4 or $5 per year per node, depending on the size of your device. Before I wrap up, this week, so this is the release of K2D. Next week is the KubeCon North America happening. I don't know if some of you are going to be there or not, but there's also a sneak peek of K2D that's going to be organized there by Neil Cresswell, which is the co-founder of Portainer. And you should be able to find a link to that event in the description of the live video that we have here, the live stream. So just feel free to go there if you wish to attend. Neil is also going to run you through K2D in general, and it's also a good opportunity to discuss it if you're interested. All right, that will be all for the presentation today. If you have any questions, I'm more than happy to answer them at the moment. Otherwise, you can always reach out to me on my email address. And as I was saying earlier, we also have our GitHub repo that's open for any questions, any form of feedback. And feel free to go on the K2D website for more details about the use case as I was talking about before. We're digging a bit more into the whys on the website. And of course, there is a documentation website available for any kind of, how to configure, how to deploy, and these kind of things. And that is pretty much it. Thank you for listening to this.
Amazing. I really appreciate you sharing that particular demo, Anthony. It really cleared a lot of my doubts. And I actually had 3 questions prepared, but all of them were cleared when you showed that particular demo and when you explained the use cases. I think the important thing for the viewers, the important thing to note here is that the specific use case that K2D actually targets and actually caters, right? And this is something that I realized while I was going through the release notes. I actually have tried the lightweight distributions that we are talking about, KOS, K3S, and MicroK8s. And one thing I did not realize was, they are lightweight and they don't, consume that a lot of memory. That is from one perspective, right? If we see from the perspective of Raspberry Pi or some kind of a device which has like 4 GB RAM or 8 GB RAM, but an IoT device which has as small memory as 1 GB, it would be pretty difficult to run those lightweight distributions, right? And that is where K2D solves that particular problem. So that is pretty interesting to note, and I think that is when it would help the viewers as well to understand where to use K2D and why to actually use it, right? So thank you so much for sharing the use cases that you shared in your particular. Yep. And I think we have 2 questions in the chat. Let me just see. So here is the first question. How does K2D interact with Cube Sphere?
I haven't been playing much with Cube Sphere. I believe that it can provision Kubernetes clusters. I'm not sure if you can actually manage existing Kubernetes environments with Cube Sphere. But if that's the case, again, K2D is trying to mimic all the APIs, all the behavior of Kubernetes in general. So if there is a way for you to manage your Kubernetes cluster in Cube Sphere by just adding your kubeconfig or trying to do a connection between your Cube Sphere installation and your Kubernetes environment, then it should work fine. So that means that you should be able to manage that device as a Kubernetes environment inside Cube Sphere. But then again, I'm not
awesome. Yep. Thanks.
I don't have any more knowledge on Cube Sphere. So.
Awesome. Yeah. Thanks for answering. I hope whoever asked this question, I cannot see their name, but it got cleared. Your doubt got cleared. And yeah, I think we have covered everything for this particular demo. And as I mentioned, all my questions were cleared while you showed. There's one question that I still have in mind related to the architecture of K2D, how that works. So
Mhm.
if correct me if I'm wrong, right? So let us take an example that I have a Kubernetes cluster, full-fledged Kubernetes cluster running on a particular device. So and I have an IoT device, let's say, which on which K2D is actually running. So will I be able to interact with that particular Kubernetes cluster through the kubectl tool on K2D that is running on that IoT device? Would I be able to do that, or am I going in the wrong direction here?
So how many devices do you have in mind here with your setup? You have a cluster on one side, then you have a device that is running K2D. That's two different clusters, or what's your how do you picture that?
Yeah, I mean, the simplest example we can take is one device which is actually capable of running a full-fledged Kubernetes cluster, right? And we have
Yeah.
another device, an IoT device, which is running K2D.
Yeah.
So will I be able to interact with that external device which is actually running Kubernetes?
Also, you mean like aggregate them together inside the same cluster or this kind of thing,
Yeah,
or not?
yeah,
Yeah,
exactly.
that's one of the limitation of K2D at the moment. We don't have clustering capabilities, so they will be identified as two different clusters, right? So your IoT device will be considered its own mini cluster on its side, and you won't be able to say, okay, I need to manage from a single kubectl command that entire Kubernetes deployment across your main vanilla distribution and that K2D mini cluster running on its side. You would need basically two different kubeconfig file, right, to manage stuff that is running on the vanilla one and then
Yeah.
on the kubectl on the K2D one at the moment. Clustering is something that we need to think about in the future. See whether that's something that we need to add into the software as well. But then again, we're looking for feedback at the moment around the usage and all the required capabilities.
Got it. Yep, makes sense. Thanks for answering. And I think this is something that I really liked about the documentation as well, that the team has actually clearly mentioned the limitations right now which the
Yeah.
K2D actually has, and it definitely shows the transparency of the Portainer community towards the end users. And I definitely believe that we'll have more and more contributors towards contributing to K2D and adding more functionalities. Coming to my next point, and this is I think the last thing that we should definitely discuss is, as K2D is an open source tool and you mentioned that you are looking for more improvements, so what are some of the areas that you are looking for more contributions, or the areas that you wish K2D to have in the future and you're looking for more contributors to get involved? Maybe you can cover that particular point as well.
We've been looking into adding more capabilities into K2D at the moment. We are still, the first one is going to be really isolating the supported resources, the list of Kubernetes resources that we really, really need to support. There are the entire IDB and K2D is also to make that usage of Kubernetes at the edge a bit frictionless. So that means I can take whatever Kubernetes resources I find online and apply it to Kubernetes to K2D. So let's say I want to deploy a Mosquito broker, or as I was demonstrating a Node-RED application, I'm just going to go online. Oh, I found this Helm chart. I'm just going to execute the Helm chart again K2D, and it should work fine. At the moment, since we don't support all the Kubernetes resources available because there's too many of them, and that doesn't fit all. That doesn't really fit with our use case anyway. We're still trying to isolate which one do we really need. Like, should we bring service account support, for example, which is a common resources that we're going to find across all Kubernetes application definitions, this kind of thing. So yeah, that's mostly the area that we want to focus on at the moment. Then there are a few enhancements of the client experience that we might need to bring, like the ability to exec into containers. I showed you that you can get the logs, but we have a few limitations. They're actually described on the website regarding what we support and what we don't. Yeah, these are the kind of things that we think about at the moment. Again, multi-node support, clustering. Uh, we also have a current PR and contribution for supporting jobs, but we need to study whether that's going to be actually useful within our current use cases. It's all going to come back around, right? Let's try to focus on these use cases. Let's try to be as efficient as we can within this frame, and not go full Kubernetes support and just go everywhere.
Yeah, then it would turn to that another Kubernetes distribution
Other
list,
Kubernetes
right?
distribution,
So
which we definitely trying to avoid. So yeah.
yeah. Yeah, cool. Thank you so much for answering, and I definitely agree. For all the folks in the chat who are interested to contribute, I'll definitely link down a few more resources, additionally to the resources already in the description box, so you can get involved. I'll definitely be trying out K2D on my personal project. Actually, we have a project in college where I'm using a Raspberry Pi, so maybe I could try using K2D in there as well because I want to run something on Kubernetes. So yeah, let's see how that goes. But
Mhm.
anyways, if we don't have any more questions, folks, let me just quickly see the chat. Yeah, people are saying it was very interesting
Thank you.
presentation. I definitely agree with that. Awesome. Yeah, I think Anthony, we have covered a lot of points today, and again, link all the resources while Anthony was sharing, and I also shared in the chat. I'll share them in the description box down below, so you can definitely check those out. And yeah, before ending the stream, Anthony, do you have any closing remarks for everyone watching and would like to share anything?
Not very much of what we've basically talked about during your presentation. We are really, really eager to hear for your feedback. So yeah, feel free to play with it. Feel free to tell us what you think about it. We'll be around trying to, innovate a bit more on that side of things and continuing to work on it.
Yep, and you can always reach out to Anthony and anyone from the Portainer team. You can join their chat server and always reach out whenever you have any doubts. Really, whenever you're trying to contribute. So yeah, I think we had a great session. So thanks everyone for joining, and we'll definitely see you in the next webinar. Then, cool.
Thanks everyone. Thanks
Bye
Kunal for
everyone.
organizing this. Cheers.